Hello students, welcome back to my channel. Today I will be discussing about acids, bases and salts. This is the second lesson of this topic. If you haven't watched the first video, then I will share the link in the description box of the first lesson. You can go and watch that video. So let's start the lesson. In this video, I will be talking about base. So first we need to know what is a base. A base is a compound which when reacts with the hydronium ions of an acid, it produces salt and water. I have already told you about hydronium ions. These are H3O plus ions that are present in an acid. So when a base reacts with these hydronium ions present in an acid, it produces salt and water. Basically, bases are the oxides or the hydroxides of a metal. Let's take an example, copper oxide. When it reacts with an acid HCl, it produces a salt, copper chloride, and copper chloride means CuCl2 and water. Let's balance the equation. Here copper oxide is base. When it reacts with an acid HCl, it produces a salt, copper chloride and water. Not only copper oxide, copper hydroxide is also a base. See, copper hydroxide CuOH2 plus an acid like H2SO4 sulfuric acid, then it produces copper sulfate as a salt and water. 2H2 so as to balance the equation. Here copper hydroxide is the base. It reacts with an acid, sulfuric acid, to produce a salt, copper sulfate and water. So both copper oxide and copper hydroxides are the bases. Now what is an alkali? I have already told you that an acid, when it dissolved in water, it produces hydronium ions as the only positively charged ions. Similarly, an alkali is a compound which when dissolved in water, it produces hydroxyl ions as the only negatively charged ions. Basically, alkali is a base which is soluble in water. Hydroxyl ions means OH minus ions. Here we will know that all alkalis are bases. All alkalis are bases. First, alkalis are the bases that are soluble in water, but all bases are not alkali because there are few bases which are insoluble in water. Let's see. There are few bases which are insoluble in water like zinc oxide, then lead oxide, copper oxide, copper hydroxide also, then lead hydroxide is also there. These are the few examples. And there are bases which are soluble in water, that means alkalis, like potassium hydroxide, okay, like sodium hydroxide, then calcium hydroxide. These are the bases which are soluble in water. That means these are considered as alkalis. Clear? Next comes to the classification of bases. First, on the basis of the strength of an alkali. So what do you mean by the strength of an alkali? Strength means it depends on the concentration of hydroxyl ions that is present in an aqueous solution of the alkali. On the basis of this, there can be strong alkali and weak alkali. Strong alkali means this almost completely dissociates in the aqueous solution so as to produce a high concentration of hydroxyl ions. Okay. And weak alkali, they dissociates partially in aqueous solution to produce low concentration of hydroxyl ions. This is the difference. Let's take the example. In case of strong alkali, let's take the example of NaOH. When it is in aqueous form, that means dissolved in water, then it will be Na plus OH minus. This is a strong alkali. It completely dissociates in the aqueous solution. And weak alkali is ammonium hydroxide, NH4OH, in aqueous solution. Okay, it dissociates into NH4 plus ammonium ion and hydroxyl ions OH minus. This gets partially dissociated. Okay. Now, next is on the basis of the concentration of the base. What do you mean by the concentration of the base? See, on the basis of the concentration, there can be concentrated alkali and dilute alkali. Concentrated alkali means they relatively have a high percentage of alkali in the aqueous solution. And dilute alkali means it relatively has a low percentage of alkali in the aqueous solution. Okay. This is the basic difference. Next is on the basis of the acidity of the bases. Now what do you mean by the acidity? Acidity means the number of hydroxyl ions which can be produced per molecule of the base in the aqueous solution. Okay, it is the number of hydroxyl ions that can be produced per molecule of the base. That means it is produced per molecule of the base. Depending upon this, there can be monoacidic base. Mono means one. That means this kind of base, when it is present in the aqueous solution, it ionizes to produce one hydroxyl ion per molecule of the base. Okay. For example, NaOH. In aqueous solution, it dissociates into Na plus and OH minus. So, only one hydroxyl ion is produced from per molecule of the base. So, NaOH is a monoacidic base. Next is diacidic base. Di means 2. Di means 2. So, it produces 2 hydroxyl ions per molecule of the base. Example is calcium hydroxide. In aqueous solution, it produces Ca2 plus and 2OH minus. That means 2 hydroxyl ions are produced per molecule of the acid. That's why it is diacidic base. Triacidic. Tri means 3. So it produces 3 hydroxyl ions per molecule of the base. For example, it's aluminium hydroxide. In aqueous solution, it produces aluminium ions. See, aluminium hydroxide, AlOH whole 3. In aqueous solution, it produces aluminium ions, Al3 plus 3OH minus. That means 3 hydroxyl ions per molecule of the base. That's why aluminium hydroxide is a triacidic base. Clear? Now, next is Lowry-Bronstet's theory. According to this theory, bases are the proton acceptors. Proton here refers to hydrogen ion, H plus. Why they are proton acceptors? See, for example, in case of ammonia. Okay. Ammonia, when it reacts with H plus ion, that means a proton, it always accepts it to form ammonium ion. So according to the Bronsted-Lowry concept, ammonia NH3 is a base. Clear? Because it is accepting a proton, accepting a hydrogen ion. Next is preparation of bases. First is bases are prepared from metals. Okay? How? When a metal like sodium reacts with oxygen, it produces a basic oxide. Like Na plus O2 produces Na2, sodium oxide. Magnesium, when reacts with oxygen, it produces magnesium oxide. So this is how bases formed or prepared from metals. Okay. Next procedure is bases are produced from basic oxides and metals. That means, see, first is a basic oxide like potassium oxide, sodium oxide. When these bases or basic oxide reacts with water, then they produce base. For example, when potassium oxide, K2O, this is a basic oxide, it is a soluble in water. So when it reacts with water, it produces KOH, potassium hydroxide. When sodium oxide reacts with water, it produces sodium hydroxide. And when an active metal reacts with water, it produces a base, but at that time it liberates hydrogen. See, when an active metal like potassium or sodium reacts with water, it also produced potassium hydroxide and sodium hydroxide respectively, but see, there is a liberation of hydrogen. Okay, so this is how bases are prepared. Next is, bases are produced from salts like aluminium chloride, AlCl3 is a salt, FeSO4, ferrous sulfate is a salt. Now, when this salt solution reacts with an alkali like sodium hydroxide, then they produce a normal salt and also precipitate a basic hydroxide. So, when aluminium chloride reacts with sodium hydroxide, it produces a normal salt, NaCl, but at the same time, it precipitates a basic hydroxide, aluminium hydroxide, which is a base. From ferrous sulfate, ferric hydroxide or ferrous hydroxide, FeOH2 can be produced. Okay. Now, next process is by the decomposition of salts. How? See, there is a salt, lead nitrate, PbNO3(2). Now, this PbNO3(2), this gets dissociated. Dissociated to which? Lead oxide, nitrogen dioxide and oxygen. So, here the lead oxide is the base that has been formed by the decomposition of the lead nitrate. Okay. Now, next is the physical properties of the base. First of all, bases are bitter in taste in aqueous solution. And next is caustic alkali. Caustic alkali like potassium hydroxide, sodium hydroxide, all these are caustic alkali. They are highly corrosive. They cause the blisters on the skin. And most importantly, bases, when they are added to a red litmus paper, then it turns blue, just opposite to that of the acid. These are the physical properties. Now come to the chemical properties. First, see, when a base reacts with an ammonium salt like NaOH, which is a less volatile base, it reacts with ammonium salt like ammonium chloride NH4Cl, then it produces a salt NaCl and a base which is more volatile, ammonium hydroxide. It gives out ammonia and water, which then reacts with each other and produce ammonium hydroxide. So, a less volatile base gives out a more volatile base when it reacts with an ammonium salt on heating. Okay. Next is, suppose there is a metallic salt, copper chloride. When it reacts with a base, sodium hydroxide, then it produces a salt and an insoluble hydroxide, a basic precipitate, which is insoluble. From copper chloride, when it reacts with sodium hydroxide, it produces a salt NaCl and copper hydroxide, which is insoluble, a blue PPT. Next is the uses of bases. See, sodium hydroxide is used in the manufacture of soaps, calcium hydroxide is used in the manufacture of the bleaching powder, whereas magnesium hydroxide is present in antacid, which actually neutralizes the acidity. I will tell you about neutralization reaction. Aluminium hydroxide is used as a foaming agent in fire extinguishers. In softening of the water, calcium hydroxide is used and ammonium hydroxide is used in removing the grease stains from the cloths. So these are the uses of bases. Okay. Now, what is neutralization? Neutralization or neutralization reaction is the process due to which hydrogen ions of an acid, H+, hydrogen ions of an acid react completely or combine with the hydroxyl ions of the base to give salt and water. So let's take the example. Suppose HCl is an acid, so it contains what? Hydronium ions or the hydrogen ions. When it reacts with a base like NaOH contains what? Hydroxyl ions. Then these ions will react with each other completely to produce salt and water. to produce salt and water. See, it will give NaCl, a salt, and H2O, water. Okay, this is the neutralization reaction. During neutralization, the hydrogen ions or the protons from the acid will be totally neutralized by the hydroxyl ions from the alkali to form a water molecule. Okay, thus here the HCl donates the H plus ion, the proton, to the OH minus ion of the NaOH, which accepts the proton to form water. Clear? Okay. Now, what is heat of neutralization? Heat of neutralization means the amount of heat that is liberated when 1 gram equivalent of an acid or the base is completely neutralized. That means to completely neutralize 1 gram equivalent base or an acid, the amount of heat that is liberated is the heat of neutralization. Okay? I think this topic is crystal clear to you all. I think I have made myself clear. So this is all for this topic. I will upload the next portion of this topic very soon. Till then, stay tuned to my channel, and if you think that my videos are informative and they are helpful, then please like and share my videos, and don't forget to subscribe to my channel. Thank you for watching the video.